there is a date that climatologists write in red on their models, 2100. Not because the world will end that year, but because if certain projections are correct, what lies buried beneath Siberia will begin to surface. And when that happens, there is no stopping it. There is a hole in the earth that local residents call the gateway to the underworld. It is not a folkloric metaphor. It is not superstition. It is a crater 1 kilometer long, approximately 50 meters deep, with ice walls reaching up to 86 meters in height in certain sections, and it is growing every year without stopping since 1960. And what is being released from its collapsing walls is not just ice and clay. It is gas. It is carbon. It is viruses 48,500 years old. It is everything the Earth buried when mammoths still roamed the land. This is not science fiction. This is happening right now. The Batagaika crater is located in the Republic of Sakha in northeastern Siberia. Average winter temperature between 40 degrees and 45 degrees. In summer, the thawed soil reaches only 1 meter in depth. Below that, permafrost, permanently frozen ground that covers 24% of the entire land surface of the northern hemisphere. Permanently. That is what the name says. But satellite images recorded by the USGS tell a different story. From 1991 to 2018, the crater's area tripled in size. The edges collapse at a rate of 10 to 30 meters per year depending on the season, reaching up to 30 meters during the hottest summers. This is not ordinary erosion. This is thermokarst, when ancient permafrost melts and the ground literally collapses in on itself, as if the earth had lost its skeleton. And I need you to understand what that means, because most people do not. Permafrost is not just frozen ground. It is an archive, a natural vault. For tens of thousands of years, it has trapped dead organic matter, plants, animals, microbes, gases, all frozen, inactive, preserved. The Batagaika crater is opening that vault. The story begins in an almost mundane way. In 1960, Soviet authorities cleared a strip of forest in the Yana region to build a road and open access to the area. Without the trees, the soil lost its natural shade. Summer began striking the surface directly, and the permafrost that had been there for 650,000 years began to melt. In the early years, no one paid much attention. A small subsidence, a ravine. An engineering issue, they said. But the ravine became a chasm. The chasm became a crater, and the crater never stopped growing. Today, residents living 30 kilometers away say that on days of absolute silence, in late autumn, when the wind dies down, they can hear the walls collapsing. Not a soft sound, a deep, low, continuous rumble, as if the earth were swallowing itself in slow motion. And here is the detail that changes everything about this problem. What began with the 1960 deforestation was amplified by something the Soviet Union never anticipated: global warming. The average temperature in Siberia has risen nearly 3 degrees Celsius since 1970. That is more than double the global average. And permafrost that survived dozens of glacial cycles was not built for that pace of change. Now comes the part that keeps scientists up at night. When permafrost melts, the trapped organic matter begins to decompose. Bacteria that had been dormant for millennia wake up, and when they consume that organic matter, they produce two gases, CO2 and methane. Methane is the bigger problem. Over a 20-year horizon, methane has a global warming potential 84 times greater than carbon dioxide. The current estimate is that Arctic permafrost stores 1.7 trillion tons of carbon, twice as much as currently exists in the entire atmosphere of the planet. If even 10% of that is released over the coming decades, the climate models we use today become obsolete, because there would be a source of emissions that no climate treaty can control. But methane is not the only problem. In 2016, a strain of Bacillus anthracis, the anthrax bacterium, was released from thawing permafrost in the Yamalo-Nenets region. The result? 2,300 reindeer dead. A 12-year-old boy died. The bacterium had been frozen for over 75 years. It was perfectly viable. In 2022, scientists led by the University of Aix-Marseille revived viruses 48,500 years old isolated from Siberian permafrost. They were dormant, intact, and upon encountering amoeba host cells in a laboratory, they infected. Within hours, these viruses infect amoebas, not humans, for now. But the same researcher warned, if these amoeba viruses survive intact, there is no reason to believe that viruses that infect animals and humans would not do the same. These viruses are called zombie viruses, not because the name is dramatic, because that is exactly what they are. And honestly, this is the point where I stop being just a narrator and begin to feel genuine discomfort, because we live in an era where we can barely manage the pathogens we already know. The idea of a library of biological agents that no human immune system has ever encountered, that is beyond my ability to minimize. And look, if you have made it this far and still have not subscribed to the channel, this is the moment. Because this is the kind of content we make. No sensationalism, no clickbait, real science in real places, with implications that no algorithm will bring you unless you are actively looking for it. Hit subscribe, turn on the bell, and let's keep going. The obvious question is, all right, but is anyone actually trying to do something about it? Yes. And the story of those attempts is as fascinating as it is frustrating. Attempt 1. Controlled reforestation. The logic is simple. Trees provide shade. Shade protects permafrost. The problem? The global rate of deforestation and the elevated temperatures themselves make reforestation at the necessary scale something that would take decades to have any effect. The Batagaika crater is not going to wait decades. Attempt 2. The Pleistocene Park Project. One of the strangest and most ambitious experiments currently underway. Russian scientists are literally attempting to repopulate the Siberian tundra with large animals, bison, horses, wild reindeer, because the trampling of these animals compacts the snow, insulating the permafrost from summer heat. It works on a small scale. In pilot studies, it reduced ground thaw by 2 degrees Celsius. But the project requires herbivore densities that have not existed for 10,000 years. And reintroducing mammoths, which they are considering through genetic editing, is not something that will happen in this generation. Attempt 3. Monitoring and containment. Satellites. Sensors. Models. What science does best when it cannot solve? Observe. And what these systems tell us is that the Batagaika crater is not an isolated case. It is the largest and most visible. But the permafrost of Siberia, Alaska, and Canada shows thousands of active thermokarst collapse points. We are mapping an epidemic of the ground. There is a concept in risk analysis called a feedback loop, a self-reinforcing cycle where the effect amplifies the cause that generated it. Permafrost is the largest climate feedback loop we know of that has not yet been fully unlocked. Think about it. Global warming melts permafrost. Permafrost releases methane and CO2. Methane and CO2 accelerate global warming. Global warming melts more permafrost, and so on. No pause button. What frustrates me, and I say this as someone who spent weeks researching this topic, is that the Batagaika crater is visible from space. It has been photographed by satellites for decades. It grew more than 200 meters in width between 2014 and 2023 alone. And yet it is off the radar of most people, not because the information is hidden, because what is happening is too slow to feel urgent and too large to be understood intuitively. Humans are not good with that kind of threat. We are excellent with jaguars. Terrible with a crater advancing 10 to 30 meters per year. Here is the cruelest part of the problem. Even if the world stopped emitting carbon tomorrow, zero emissions overnight, the permafrost would continue melting for decades, because there is a lag between emissions and temperature. The heat we have already put into the atmosphere is still being absorbed. We are paying now for emissions from 30, 40 years ago. And today's emissions? They will send the bill after 2050. Scientists call this committed warming, the heat that is already guaranteed, regardless of what we do from this point forward. For the Batagaika crater, this means that even in optimistic scenarios, it will continue growing until at least the end of this century. The hole that began with a Soviet road in 1960 may become one of the largest permafrost craters on the planet, and every meter it advances releases more of what was stored inside. There is a painful irony here. The more science understands permafrost, the clearer the scale of what we cannot control becomes. The Batagaika crater is not a tragedy of the past. It is an ongoing process. Right now, as you watch this video, its walls are collapsing, releasing what has been trapped since before our civilization existed. This is not a reason for paralyzing panic. It is a reason to understand, and understanding begins with not looking away. If this video changed something in the way you think about what lies beneath our feet, let us know in the comments. And I have a specific question for you. Of the 3 risks we covered today, methane, zombie viruses, and ground collapse, which do you think will have the greatest impact over the next 50 years? I have my own opinion, but I want to hear yours first. Dead zones. Because the most extreme places on Earth have the most important stories.